It's a pleasure to be with all of you here today, and we're very pleased to have our expert guest speaker, Steve Kubler, with us here too, who I'll be introducing in just a minute. So welcome to our webinar on finding money in the water system budget, energy management project ideas, prioritization methods, and implementation planning, which that's kind of a mouthful, isn't it? We are the Environmental Finance Center Network, and we are a group of environmental finance centers, university-based applied research centers around the United States who work to promote sustainable environmental solutions, including through this project, the Smart Management for Small Water Systems project, funded by a cooperative agreement with the U.S. EPA. The project is nationwide in nature, and we're doing a lot of things in all states and territories for small drinking water systems serving 10,000 or fewer people, including this webinar series. So we offer individualized technical assistance, workshops, small group support, webinars, e-learning, online tools and resources, and more through this project at no charge to you, the small drinking water systems. This is who the member institutions are of the Environmental Finance Center Network, including us here at the University of North Carolina, Chapel Hill, and my colleague Laura, who you just heard from Syracuse University's Environmental Finance Center. These are the different subject areas within the Small Systems Project where we are working, and today the focus is on energy use and efficiency. Here at the UNC Environmental Finance Center in Chapel Hill, North Carolina, we are dedicated to enhancing the ability of governments and other organizations like yourselves to provide those environmental programs and services that you offer in fair, effective, and financially sustainable ways. And we have a saying at our neck of the woods of how you pay for it matters. This is the third webinar in a series of 4 energy management webinars. The previous 2 have already been archived on the project website, which you can see at the bottom of the slide there, efcnetwork.org. So the slides and the video recordings are already there if you missed it and want to go back and hear them. We will have a 4th and final one coming up in September on special financing models for energy management projects, the all-important question of how do you pay for it. So please do tune in for that and spread the word. Tentative date is September 15th, but we'll be firming that up and spreading that word on the website and with emails to folks. We are privileged that there are 323 of you who registered for today's webinar from around the United States. By my count, I believe it was at least 46, if not more, states included here, as well as the District of Columbia, Puerto Rico, and someone from the country of South Africa. So if you're on the line, welcome. The speakers for today's webinar are Steve Kubler, the installation technician at AWI Incorporated in Utah now, but he is also the longtime former water and wastewater systems supervisor for the city of Chanute, Kansas, and he'll be speaking especially from that expertise base on doing energy management. I'm afraid that should actually not say Lisa, it should say Laura. My apologies, Laura. Laura and Lisa work closely together at the Syracuse University EFC, and myself. In just a minute, we'll be hearing from Steve about his on-the-ground experience and success stories with energy management. I'll speak after him for a little bit about prioritizing and implementing your projects. As far as the energy management project ideas go, we could spend an hour or 2 or a whole day just on the whole panoply of ideas that are available for projects for all different kinds of systems. So we're just going to give you a sampling there. In fact, there will be more slides on that area than I will have time for on air, but you'll still be able to access more of that offline if you wish. And we will have, as Laura was saying, Q&A at the end and wrap up by the end of the hour. We have a few polling questions we would like to ask you to do to help us to get to know you and who is on air with us right now. So I believe Laura is launching the first one, and you should see it on your screen there. What kind of drinking water utility do you represent? So if you could click on the appropriate button there, we'll give it a few seconds and see who's on air with us today. All right, this is great. A lot of you are voting, so that's excellent. Laura, why don't we, I know that they're still clicking the buttons, but why don't we go ahead and put it up there? Very good. And it looks like we have a plurality of you who are local government owned drinking water systems, and quite a few of you who are not drinking water utilities. I imagine a number of you are still in the neighborhood, though, as consultants, engineers, and other professionals in this area. So the next polling question, which Laura will launch now, is what size drinking water system does your utility operate? In this case, by the number of people served, not the number of connections. And that goes to the question of our project, where it's focused at systems serving 10,000 or fewer people, though for events like this webinar, all are welcome to tune in. Okay. Very good. All right. Thanks for sharing those results up on the screen, Laura. And it looks like quite a few of you are in the 501 to 3,300 people served category, and a good spread across different sizes. And again, considerable number of you who are not drinking water utilities. So that's good to know. And I recognize this is not a comprehensive list for the third polling question that Laura is about to launch here. But just in these broad brushstrokes, I'm interested what kind of energy management projects you're most interested in for your utilities. I suppose if you're not a utility but you work with utilities as a consultant, you could answer that on the basis of what you see those utilities are telling you they're the most interested in terms of energy management. And so, as you can see on the screen, we tried to cover some of the principal categories here, like pump motors, process changes, lighting and HVAC upgrades, trying to change your rate schedule if you can with your electricity provider, as well as one of the very first steps, which is just getting an energy assessment if you haven't had one already. All right, so let's see what we've got here, Laura. Y'all have covered all your bases there, which is good. So, we'll be able to speak to a bunch of these different points within the framework of today's webinar. All right, so moving right along, I'm going to complete the process of introducing Steve Kubler now and turn it over to him. Steve is, as I said, an installation technician working for AWI, which is Anthrotech US Incorporated, based out of Sandy, Utah, and he's been with them since last year, since 2014. But before that, Steve worked for the city of Chanute, Kansas, for many years. And Steve, you worked with the city's wastewater treatment plant, becoming the chief operator and the supervisor of it in 1987. And then in 2007, you took on supervision of the water treatment plant as well. And you retired from that job in 2014. And among your various achievements during your time of service for Chanute, Kansas, I see that you were chosen City Safety Coordinator. You worked part-time with Community Relations Specialists as well on a contract with the EPA on a Superfund cleanup. And Steve graduated from Chanute High School, Fort Scott Community College, with an Environmental Water Technology AS degree. You've attained Class 2 Wastewater Treatment Plant Operator Certification and frankly, too many certifications to just read all of them on air right now. Suffice it to say, Steve's a real expert in this work on the ground. And Steve, why don't you take it away?
Thank you, David, and hello to everyone. When I got into energy efficiency at the plant, it was based on the fact that it was an old plant, built 1950s, the water plant was, and it was just getting older, more expensive to operate. However, as most of you know, budgets don't tend to go up very quickly. So I was looking at ways to find the money to do the work that needed done, and I got involved with the Environmental Finance Center out of the Wichita State University office, and did some seminars with them, and got into calculating how to fund and justify projects that would replace the equipment I needed replaced and save energy in the process. In the process of this, I discovered there's two kinds of projects. Small projects that you can fund internally and just do in the course of business, such as changing out LED bulbs into, for fluorescence, putting the LEDs in instead of fluorescence, I should say. And then the large projects like pump motors, windows, boilers. The first project I started with, I used this spreadsheet, which came from a form from the Finance Center, to calculate out a replacement cost and how long it would take to pay for. I originally intended to go from T12 to T8 bulbs, and if you look across the total cost per year, that includes the change out, the cost from going to T12s to T8s was, significant change from $61 to $42 a year. But when I threw in LEDs, I saw, it went less than half. And this was, kind of shocking to me. I did not expect to save that kind of money. So we started this process, and not only were we able to go to a 4-bulb LED fixture, we dropped to a 2-bulb LED fixture and promptly got down to the electrical cost of $7 a year, annual cost counting change out of equipment to about $11.50 a year, and that paid off in less than 2 years at the 2-bulb fixtures. They're still changing them out now. They're doing it in phases, and one of the advantages of LEDs was our fluorescent bulbs were over some of our water tanks. They contain mercury. If you ever broke a bulb while changing it, you had a problem. LED bulbs are much more robust and also contain no mercury, so that was a big bonus to our process. The same form can be used for many other projects. We use them to calculate out the motor if it change out. I did not get that sheet. Now that I'm not with the city, I don't have total access to everything because I can't find it. But the motors came out to about a 15-year payback on average. And while we wanted to do motors, the 15-year payback and the price of the motors, it took away some of the other things we needed to do. Our current motors were working. So we put that into a 10-year process to change out instead of doing immediately. One of the other things we did on an externally funded project instead of internal was have a audit done to determine what the overall costs were for various parts of the buildings. There's a sample of a page out of our audit. They showed that changing out a boiler would cost around $60,000 a year, and our windows on the heated and air-conditioned floors would be about $27,000. The came up to a 20-some-year payback. However, at the same time, our boiler was installed sometime in the 70s and was in quite poor shape. Our windows were installed in the 50s and were just falling apart. I used the audit and managed to get a loan with a 40% write-off for energy efficient processes. So that amounts to a $40,000 savings over the cost of the program to install all this. When you do the external audit, that's one step that you have to do for the loan, and I know that'll be in the more finance information will be in the next seminar this fall. But that makes for a huge saving when you get to work into one of these loans that have the write-off program that are sometimes available. The boiler and the windows have been installed. The boiler is a 92% efficiency compared to the old one, which was 70 when it was new, and is probably much less than that when it was installed. The windows we put in were double hung, filled out so you can clean them windows, and it's made a huge improvement in not only the energy efficiency of the plant, but also the livability. We no longer have drafts, we no longer have insects coming in and out of the windows, so our filters don't get covered with bugs as easily. And it's just made for a much nicer facility overall. There we go. I got a graph of our gas consumption, and you can see how it dwindles off as the years go by. The 2010 there in the bottom marks about the time the boiler was installed. This graph comes from a utility company. It's quite useful. The electric also shows a consistent drop over the years. It's hard to get an exact cost savings for these projects because, as you know, there's many electrical and devices throughout the plant that use much more power than the air conditioning system uses, the pumps, the clarifiers. So I have not been able to get a total cost savings, but means we're seeing a constant drop in our graph. That shows me that we have made an improvement over the years to our electrical usage. Some of the other projects we considered that I didn't have much information to make slides on was a roof installation. Oops, sorry about that. The roof, they wanted us to put an insulated roof in. Well, our current roof is not in good shape, but it was also not bad enough the city wanted to fund it. It's about a $25,000 project, and that would pay off in over about 18 years. The decision was made to put that in our 5-year budgeting process and to install a new roof completely, not to just put insulation up underneath the top of the current roof, and put in a poured foam roofing process at the time. That will basically kill two birds with one stone by putting a new roof up there and also the insulation. The wall insulation was also discussed. It's a concrete wall building, and although that would save $16,000 a year, it would also cost $52,000 to install. And they figured a 15-year payback. The problem with that is in a water plant, all the filters are on the inside of the building, so the building has a very high humidity level. There was great concern about the humidity soaking into the insulation and not only damaging it, but also ruining its insulating capabilities. So we have held off on that until they come up with perhaps a better choice in plans. Insulation. We also changed out our meters in the inlet structure of the plant. The water loss in a system can cost you a great deal of energy because you have to pump that water. And in many cases, you treat the water before it is, disappears. The meters within the plant were all calibrated, and that's done on a regular basis to make sure they maintain accuracy. The new meters at the inlet structure are designed to report back to the plant so we can see what water is coming in. And also, if like a check valve gets stuck open, we can see that it's flowing back out through the other side. There's two lines coming from the river. So that with the backwards and forward flow capability is very handy. And being able to track our water loss accurately let us focus on where we had problems in the system to figure out our water loss. I don't have cost estimates for that, but I do know had seen a high of around 15% water loss. Last year was 11. And getting that down below 5 is kind of a goal that I think is reachable. This rolls into the job I do now. Working with AWI, we do filter optimization, and part of our task there is to reduce the amount of water wasted in backwashing and to make filters more energy efficient overall. It's quite interesting, and got into that through my work with the city. David, that pretty much takes care of most of what I have. I'm sure people have questions, and I'm more than happy to answer them. Trying to think of another project in hand, but I don't have one right now. So,
well, thank you very much, Steve. I'm going to get my slides back up on the screen here. People will bear with me. And there are some questions for Steve, but we're going to save them for a little later. And here we go. Thank you very much, Steve. So we're also going to talk today about energy management projects in terms of how to prioritize them, how to implement them, and a few sample ideas of projects that may be of interest to at least some of the systems, if not all of you who are on this webinar with us. We have been basing our webinar series in many ways around a model developed by NYSERDA. Now, for those of you who are not familiar with them, they are the New York State Energy Research and Development Authority. And that's their website right there. They were founded as a public benefit corporation in 1975 during the energy crisis of the 70s. And they've been working ever since then to help folks to save on their energy costs and be more energy efficient and help protect the environment, including work that they've done in relationship to the water and wastewater sectors. So they've been of great value to the state of New York, but also to all of us around the country who've been able to tap into what they do. And we'll come back to their model in just a moment. But just to review for folks who may not have tuned into the first or second webinars or have encountered us at all yet through our energy management work, should a small water utility care about energy? I would say yes. This is based on one study of your variable costs, your typical water utilities O&M costs, and energy tends to be the largest controllable slice of that pie. And vis-a-vis the primary and secondary goals that water utilities across the country have to meet. Number two, providing services for reasonable and fair user fees or rates. Well, your energy costs go into your overall cost structure and therefore have an impact on rate setting and fee setting. So it's definitely something that I think all water systems should look into. So just a little more on those lines. According to a study in the AWWA's journal by Rainier and Winters, 2 trillion gallons of water are pumped each year by small water systems, using approximately $1 billion worth of electricity every year. So if all of them collectively could only save 1% on their electric costs, that would be $10 million, or 10% savings, which may be very, very doable. That would be $100 million a year across all of you around the country. Can you do it? Definitely. All of you are going to have different kinds of situations, different kinds of utilities, projects you have already done or have not yet done. But depending on what kind of system you have, these are some examples of things you might look at. Working with your pumps tends to be, for most of you, I know the biggest energy charge is for pumping. And so do you want to put variable speed drives on your existing pumps or premium efficiency motors to replace your current motors? Optimize the high lift pumps, work on the flocculation coagulation system, work on the filtration. I'm going to kind of go past this a little quickly now so that we manage to get to the rest of the material. Also, there's possibilities to save energy on your disinfection system. If you have a UV system, is it operating in an energy efficient manner? You can look at the energy management of your residual management and other areas too. If you have HVAC equipment, if you have lighting, for all of your electricity, if you're on an electric rate schedule that includes demand charges for power for your kilowatts of demand, then some load shedding or load shifting to off-peak times may help to reduce charges there. And I should add that in all of this, our webinars tap into a broader amount of knowledge that we have on energy management, and if there's more that you want, after today's webinar, after the end of the series, you can contact us if you're a small system, and if you have a particular problem that we can help you with, there'll be an opportunity for some direct technical assistance. We'll talk about that later in the hour. And here, going back to NYSERDA, is their 7-step model. So the first 4 steps were covered by my colleague, Dawn Nall, in the previous webinar a few months ago, to establish an organizational commitment, develop a baseline of energy use, evaluate the system and collect data, and identify energy efficiency opportunities. So in today's webinar, we're going to assume you've done all of that. And now you're up to steps 5 and 6. How do you prioritize these projects you are thinking about? And once you prioritize them, how do you implement them? Because these are pretty key questions, especially when time and money are in limited supply, as they usually are. So this 5th step on prioritizing opportunities for implementation. We'll talk a little bit about project economics, then prioritizing more broadly, and we'll show you a brief exercise that you can do offline. So when you're prioritizing your opportunities for energy efficiency, you'll want to have projects that you've selected carefully, evaluated them carefully, and you'll want to identify a consistent method to compare and rank opportunities, considering both monetary factors and non-monetary factors. Naturally, money is a big piece of it, isn't it? So you saw on one of Steve's slides where he calculated, at least one of his slides, where he calculated the payback periods. And for any of you who are not already well versed in this, it's basically taking the cost of the project and dividing it by the savings per year, and then the number you get should be the number of years it takes to pay for itself, 3.5, 24.5, 0.5, whatever it is. So this is not taking into account the time value of money, which we'll talk about in just a moment. It's just looking at, dollars as all being the same as each other, and how many years does it take to pay back. So an example, let's say you've got a project A you're evaluating, whether to replace pump motors with more efficient models. The new pump motors would cost you a total of $200,000. If you put them in, they're going to reduce your energy costs by $100,000 a year and last for 5 years before you need another one. These are all made-up numbers, by the way. And so the simple payback period for Project A is 2 years. And then after that, you start getting the gravy for at least 3 more years after that before these imaginary pump motors need replacing. Now, there is a question of savings versus avoided costs, and a lot of people, this is going to be completely obvious to them, but maybe not everyone. And it goes to the importance of communication with your stakeholders too. So taking this example here, we can see how for the residential electric price there per kilowatt hour, You know, it went down from 2007 to 2010 in absolute terms. So by the same token, if your total energy expenditure went down from, say, $9,000 to $8,000, it's obviously a savings. But, you know, what if it was scheduled on your projections to go up from $9,000 a year to $12,000 a year, but you put into place some measures that, you know, bent that curve down a bit, so it only went up from 9 to 10. Well, some people might say, well, that's not a savings, but you avoided some costs, so it's still a kind of savings. It's just important to be able to communicate this clearly to folks when you're drawing up the projects and implementing them and wrapping them up. A life cycle cost analysis looks at not only the initial cost of the project, but all of its costs and benefits over the lifetime of the project. And that typically will include some time value of money calculation. And you'll want to be looking at volatility of cost when you do your life cycle cost analysis, and any operations and maintenance costs that are related to the project. So, you know, maybe you replace an incandescent light with an LED light, and now it's going to last years and years longer. So not only are you going to save on your electric costs, but you may cut your, you know, maintenance costs down too as well. Net present value, which we'll just touch on very briefly, this is a method of taking into account the time value of money. And so the basic idea that I would point out here is, you know, if someone says to you, hey, I've got $500 and I'm going to give it to you, and would you like it now or would you like it 10 years from now? Well, pretty much all of us are going to say we'd like it now, if that's the only context, because if we wait 10 years, well, gosh, we could have been doing great stuff with that $500 in the meantime. We could have put it in the bank, could have earned, you know, whatever, 3% interest on it across 5 years. So when you're trying to compare apples to apples, looking at different potential projects that would start at different times, end at different times, you want to take into account the time value of money by discounting using the net present value approach. And the formula is down there, and if any of you use Microsoft Excel, it's got a handy dandy command that you can just use in a cell there, and it's fairly self-explanatory. Probably this is of less concern to people, especially at a time of very low inflation and very low interest rates. But it still is a useful thing to do when you're trying to compare projects across the long haul or even the short haul. One of the other things that NYSERDA provides is a payback analysis tool. If you want to take a look at that, this is the link to it. And all of these slides will be emailed to you after the webinar in the coming days. The U.S. Department of Energy maintains a very useful resource called Motor Master, which gives you technical specs on motors, including how energy efficient or inefficient they may be. So that's a useful thing to look at. And DOE also has some info on how to do life cycle cost analysis for sustainable buildings. So how would you go about prioritizing a lot of competing projects? There's definitely more than one answer to that. I'm going to show you one approach, then I'm going to show you a second approach here. So in the state of Kansas, the AM Can Work partnership, which was between the New Mexico Environmental Finance Center and the Kansas Department of Health, put together this energy project decision matrix that you'll see in just a moment. And it was, in particular, I believe, intended for water, wastewater utilities. There we go. So what are your project priorities? Well, it could be a lot of things, maybe some things that we didn't get on this list here, but some of the principal things would be energy cost savings, cost or ease of implementation, what the simple payback period is that we were just talking about, if there's any regulatory compliance or level of service goals that you need to meet, whether or not you can gain access to advantageous funding availability, like, say, a low interest or zero interest loan from the SRF, the State Revolving Fund, for example. or a grant for that matter. Operational feasibility and plenty of other things can go into it. Now this is a look at the energy project decision matrix we were just talking about, and it's an attempt to capture many of the principal categories that may be necessary to evaluate, and then to evaluate each of those categories for the project. You know, you get one project per line there, from 1 to 5 points. So energy cost savings, cost of implementation, a number of the things we were just talking about there, all the way to, is it part of a larger project? Because sometimes that's going to increase the likelihood that something will happen, like if your entire, you know, city or town or county is adopting a big energy plan and the water system is going to be part of it. So when you're scoring it, if you use that, you know, like I said, score 1 to 5, bigger numbers are better, more points are better, more attractive. And all of us will do better than this poor chap here in the dunce cap, I'm sure, with that. I will not belabor this one right now, but this expands on, you know, what's intended for each of those categories, each of those columns that you just saw. So some things to take away from this matrix is that it allows you to compare and rank projects on the basis of those 6 or 8 categories. Higher scores tend to be better, but a caution is if you use this tool, the way it starts out is all columns are weighted equally. And you, in fact, may want to consider some columns as more important than others. You may want to say, hey, energy cost reduction, that is far and away the most important thing to us. Or you might say a regulatory compliance factor is the most important thing because first and foremost, your business is to be providing safe drinking water to folks. So you can adapt it to your use, add or delete columns. When you do this, it's useful, number one, to have an energy team, so it's not all just falling on one person at your organization. And number two, to involve your energy team in using this and discuss the evaluation criteria together. In fact, you might all fill it out separately. You can set weights for different columns. You know, maybe one column gets 50% weight versus everybody else put together. And there may be some things missing from this matrix for some of you. So that could potentially include ease of implementation, which may be not just a dollar cost matter, but, you know, how much time and effort do you have to put into it? How long is it going to take for this solution to be fully implemented? What's the cost to maintain it? Is there support for or opposition to the solution within your organization, within your community? How enthusiastic are team members? Hopefully vary, but, you know, might depend on the project. Potential effects on your customers, potential problems during implementation. And if you're doing this or the next exercise that I'll show you, which is a little more graphically based, if individuals on the team fill out either of these exercises separately and then you assign different ratings to the same project, the same criterion, it's good to discuss it together around the table rather than just mathematically averaging out the ratings. And the reason I say that is because all of us bring somewhat different expertise to the table, don't we? And you know, you may have a case where discussing the differences brings out something that only one person at the table knew, but everybody needed to, and I'll say more about that in a moment. So here's the little exercise where if we were doing one of our energy management workshops like we're doing in several states, we'd sit around the table and do this together in person. This is, as you can see, a 4-quadrant grid here. And the idea here is that on the y-axis, the vertical line on the left, we're looking at the effort and or cost required, so dollar cost and other kinds of, you know, time and effort, going from low to high, from bottom to top. And then on the x-axis, or the horizontal line on the bottom there, your energy savings going from low to high. So in the lower left quadrant, these are the quick hits, the things that don't cost you much, don't save you much, but they give you a little quick hit of something good. To the right of that, in the lower right, you could call them your gems, the projects that have a low cost but a really nice big payoff. And We'd love for everything to be under the gems, wouldn't we? But that's not necessarily the case in real life. In the upper left, low priority projects. They cost a lot. They don't save you so much, so you might get to them, but probably further down the line, or you might bundle them into a package of projects along with more attractively, more attractive propositions. And then in the upper right, we have what you could call your sort of traditional concept of capital projects. There's a high cost involved, but a high savings. Like replacing all the windows on a building like Steve was talking about. That tends to take time and money and takes a while to pay for itself, but then the payoff is oftentimes pretty significant if you're getting energy efficient windows. So let's take 4 imaginary projects here. Lighting upgrade A, the first one, lighting upgrade B, high service pumps, and HVAC and window films. So HVAC, of course, being heating, ventilating, and air conditioning. And by window films, we mean if you have an existing window and it's not an energy efficient window, it's not a low emissivity window or low E window, but you're not prepared to replace the window itself just yet. There are vendors who sell these films that you adhere to the window and will reduce the heat gain. So lighting A, you'll see there's no cost. It's just getting in a good regime of turning the lights off, say in the evenings or at night, and can potentially save you 40% there. And simple payback time is going to be 0, immediate payback. Lighting B, you're spending some money to go from T12 fluorescent bulbs to the narrower diameter T8 fluorescent bulbs. So that's costing you $12,470 and paying back for itself in just over a year. With the high service pumps, replacing high service pumps with premium efficiency ones at 2 pumping locations. And this is costing you over 50 grand and will pay for itself in just under 3 years. The replacing your air conditioning with a high efficiency system and installing the window films so that you don't have to run the AC as much. That's going to cost you over 218 grand there and pay for itself in over 3 years. So taking these 4 imaginary projects, you can try and hold that in your mind. Where might they go on the grid that we were just looking at? So I would say that different people will come to different conclusions, but I would put lighting A in the quick hits. It's free, but only saves you a little bit. Then going to the other extreme, because I think the easiest ones for me to peg on this grid are the first one and the last one. So going to the other extreme, the HVAC and window films, I'd say that's a capital project. I mean, it costs over 200 grand, and it's going to take a few years to pay for itself. And then where do we fit in lighting B and the high service pumps? Well, that gets more debatable. My take on it earlier today was lighting B is still a quick hit, but you see it moves up the cost axis some, as well as moving to the right some on the energy savings because they're bigger. You see it's more than twice as much energy savings. And then finally, the high service pumps, it's debatable where they go, so I just kind of plop them right down in the middle. So if you find this helpful, recommend this exercise to you, and you could just print out this slide from the slide deck once you have it. So some keys to success on prioritizing are converting all energy efficiency opportunities and their characteristics to a common denominator, and money is one of the good ones to look at, though as we said before, there are other non-monetary things to evaluate. Look at the ancillary benefits and the ancillary costs when possible. If you have the time, and I think it's good to do this, test the sensitivity of your results. So for example, what if our calculations are based on electric rates today, but they go down a bit, which actually has been known to happen occasionally. Probably some of you are laughing out there, but I have seen it happen. Of course, you can also test how does it look if the rates go up, because it'll probably look even more attractive to you. And you can test the sensitivity of other variables in your analysis as well. You want to make sure that the final results make sense in terms of your utility's capabilities, which goes to your ability to implement it, which is our next topic here. So we'll have to go a little fast through the implementation section, but I do want to cover it. because it's the sixth step in the NYSERDA model, and we're breaking it down into 4 pieces here. The first step, defining your project objectives and targets. Second, identifying the tasks necessary to meet your project objectives. Third, identifying changes to any SOPs, standard operating procedures, and to your process control. And step 4, determining project time frame and resource allocation. So for the first step, you'll want to identify your project objective, and as you create your implementation plan, and identifying your project target will help you determine the success or likely success or not of implementing your project. So your potential energy project management objectives could be reducing energy cost, reducing petroleum consumption, reducing peak energy demand if you're on an electric rate schedule that gives you demand charges, reducing greenhouse gas emissions from the electric utility that's supplying you electricity, because most folks still have got, you know, fossil fuel-based generation in the mix in a large way. Improving reliability can be an objective. Increasing the use of renewable fuels could be an objective if you can factor that in somehow. Or reducing maintenance costs, like we talked about before, such as with longer-lasting lights or other kinds of equipment that doesn't have to be replaced as often or is cheaper to do maintenance on. When you're setting your objectives and targets, you'll want to think about your ability to control the operations of the equipment, your ability to track and measure progress, savings, costs, as well as the cost involved in doing the tracking, because there's going to be some administrative cost for you to do that. So someone will need to be assigned to that task. Progress reporting itself is a valuable and important thing to do, especially if you're going to keep all of your stakeholders in the loop and build on this project with future projects across time. And any linkages to your overall energy policy. If you have one, if you don't, you may want to adopt one for your organization. So as an example, let there be light. We've heard that somewhere, haven't we? And so we got an imaginary facility, XYZ. They have prioritized, their top project's going to be to replace their existing high-pressure sodium lights with LEDs. So what are some possible objectives of this improvement? Well, probably reducing energy costs, of course. But they may also be interested in reducing maintenance costs, because LEDs tend to last for a long time, don't tend to take a lot of maintenance, and so reliability might be an issue. What would some of the targets be, the performance targets? Very likely you're going to be looking at your ability to track and measure the progress there and be able to show, you know, that the savings is happening and the project was worth it. Among other things. So step 2, identifying the tasks necessary to meet your objective. You'll want to identify the individual tasks underneath your project, the mini goals that will get you from here to there. Step 3, which we're going to divide into 2 parts here, and I'm going to have to wrap up pretty soon on the implementation section here. So essentially, any changes that you're doing here to your standard operating procedure, operator duties, equipment maintenance, treatment processes, emergency response, you'll want to take that into account and plan for that. As far as your process control goes, does your facility use automation? And if so, are you going to have to reprogram something for this? So if you're, you know, if you're a wastewater treatment plant, say, and you're changing out, you know, your frequency with which you run your blowers, is it tied into your dissolved oxygen meter, you know, properly, so that you're still running them often enough to maintain the proper levels? And are people trained in what they need to do? And step 4, determining project time frame and resource allocation. How long will it take for the tasks to be completed? Who's going to be responsible for them? How much time will that person have to spend working on it? How much will it cost to implement it? So summing that up for the LEDs, staff, timeline, estimated time, estimated costs. And I'll only show you just one project here, since we need to have time for the questions and answers. And any of you who haven't already done so, please type in your questions right now for us. So all of you probably have got some pumps. Even if you're a purchase-only system, you've got some pumps. And those pumps have got motors, and you may want to see if they're the right size or not. Do they need to be smaller or larger before you even look at changing out the motors or putting VFDs on the motors? So this condo complex in Highland Beach, Florida, they are a drinking water system, and they put on variable speed drives, variable frequency drives, same thing. You can see pictures of them here. And they were able to also install solar panels, heat pumps, do energy efficient lighting. They went to town on their facility, and they ended up saving about $2,000 per month on their water bill because they're an end user of water, different kind of water system from a local government system. And they've saved $24,000 on electricity. So we're going to try and take some questions for you now, and these slides that I didn't get to, you'll still be able to check them out yourself offline. So before we get to the polling questions, let me see what kind of questions all of you have typed in here. And I've got a question for you, Steve, and that is, when you were looking at projects and prioritizing projects like the ones you described there in Chanute, Kansas, did you ever look at doing retro commissioning of any of your equipment there, where engineers come in and basically give them a tune-up?
Well, not totally. Our motors, our largest motor is 100 horsepower, and having it rebuilt, if that's what I'm taking that right, compared to replacing it, we did do like gearboxes, put new bearings in them, things like that. But on the electrical side, no, we never did that.
Okay. And here's another question that I'd like to direct to you, Steve, which is, from your experience, how much variation in energy efficiency for motors currently available exists? Is it small? Is it considerable? Does it depend?
It depends on the size of the motor. As far as I understand, I'm not a real big motor guy. The biggest difference I saw was the number of hours the motor ran. If you had a motor that ran 24/7, your savings could be considerable. A lot of our motors were varied, so we alternated them often. So we'd have to change a lot of motors to get 24/7 coverage, basically, which is what hurt us. If you just had one or two that ran pretty much all the time, the savings jumps way up.
Right. Thank you, Steve. And there's a question about, are there funding programs, grants, or low-interest loans for-profit water systems to help with implementing energy efficiency projects? I would say tune into our next webinar for a longer discussion of that. But the shorter answer is that vis-a-vis funding programs that come from the states or the territories. And of course, there are other funding programs out there too from private organizations. But the regulations are different in different states and different territories. But I've definitely seen ones where if you are a community water system and you are in compliance with all of the laws and regulations, but you are a CWS, then yes, there are cases where, as a for-profit system, you know, perhaps you're a condo complex, for example, where you could apply for a grant or a low-interest loan. Again, it's going to depend on where you're located and what exact program you're talking about. Steve, I'll direct this question to you. What kind of payback period would you consider, thinking back when you were working for Chanute, would you consider reasonable for spending capital for energy efficiency improvements?
I always use 7 years or less would be higher on my priority list. Anything longer than that would have to have other benefits besides just payback, if that makes sense. So, you know, if it was a 20-year payoff, it had to have another reason to be done. But, you know, if it's less than 7, I'd do it just for the saving of energy.
Right, right. And the only thing I would add to that from what I've seen to what Steve just said is that, you know, sometimes you will get funding for something internally or externally for a whole package of improvements, and then something that might have had too long of a simple payback period to be done in a standalone way will still be considered acceptable as part of the package, where the simple payback period of the whole package is a shorter, more acceptable number of years. Steve, you were an operator for a long while, and one person asked, how involved are you as the operator, or were you as the operator, in viewing the costs associated with utility operations? Were you conscious of each component's consumption of energy, such as, pump by pump or motor by motor?
Yes, we actually pulled amperages on all of our equipment and kept track of that early on in my career, and that would be a good way to do maintenance as well, to see if it started pulling more. But yes, we looked at every item in the plant. I did day-to-day management of the plant and all the budgeting and paying the bills as well, so I knew what equipment was using the most amount of money, to keep it maintained, as well as keep an eye on the energy use.
Very good. Well, I think we have one or two other questions that we'll try and answer off air with y'all, because we do want to wrap up here with Laura's help by asking you, all of you, just a couple more final polling questions. So we here at the UNC Environmental Finance Center, we have a very active blog. We blog every week about matters related to water and energy, stormwater, wastewater, the sustainable financing of all of that. And if you're interested in being added to the blog, just click yes there, and we will do that. And we're not going to do anything weird with your contact information. We just add you to the blog, and we've got over 2,000 subscribers to it already, so we'd be glad to have you join us in. All right, well, let's close that out now, if you would, Laura, and I'll move us on to the next polling question, which is, as I mentioned earlier, the Small Systems Project. So if you are a drinking water system and you serve 10,000 or fewer people, we have, a limited ability around the country to do some direct technical assistance for your small water system on energy management, but on other things too, rate setting, financial planning, water loss reduction, access to funding, etc. So we have ability to do some direct work with you for no charge. If you're interested, go ahead and click yes there. If you are not, no, and if you want to know more than what I'm telling you just briefly right now, then click that. We'll get back to you. Lisa should have just pushed out to all of you a survey. If you have time to do it now, that would be great. If you don't, then it's going to be emailed to you automatically, I believe. It's just very brief. It's just a few minutes, but it gives us feedback on what we're doing well and what we could do better. And it helps us give feedback to our funder at the U.S. EPA, at the Office of Water there. So we really appreciate all of you tuning in today, and thanks for all of your great questions and for being with us this past hour. Steve, thank you very much, and Laura, again, I should say Laura, not Lisa, my bad. Thank you very much for your help, and hope you all have a great afternoon.